Hello, welcome to the Master of the Skies weather briefing show. I'm weather forecaster Lionel. So in this episode, we're going to be concentrating on the flash flooding event that occurred over south central Texas on July 4th, 2025, that produced that catastrophic flash flooding event and unfortunately resulted in quite a bit of fatalities. Which was extremely sad. And so in this episode, we're going to be concentrating more specifically on the meteorological factors that came about to bring on this really tragic event. So some of you may have already seen this footage on social media of this video of the water levels increasing very rapidly. Of course, this is a sped up video, but it shows you how quickly rivers can flood when you have extreme rainfall rates falling over a watershed and trickling down the affluents into the main river. It's almost like a tsunami that comes raging down the river in a very short period of time. As it turns out, the water levels in this event actually rose about 8 meters in a very short amount of time, which is extremely fast. And so if you're actually anywhere near the river and this is occurring, you may have a very limited time to actually escape. And when this occurs at night, as this event occurred, also in terms of the initial water levels rise, it can be quite catastrophic if you're too close to the river. And so we're going to be taking a look at a little bit what actually went into this event, concentrating on the meteorological factors. But before I do, I extend, of course, my deepest thoughts to the families that were impacted by this tragic flash flooding event. And my heart goes to all the people affected. Very sad. So if we take a look actually at this water vapor satellite imagery, this is imagery from the Cooperative Institute for Research in the Atmosphere out of Colorado State University. And you could see this is actually the mid-level water vapor band number 9 product from the GOES-19 weather satellite. And it spans a 2.5-day period from July 4th to July 6th, 2025. And basically what you see on this imagery is all the bluish tints. The bluer and the darker blue indicates really cold cloud tops. And so you're basically looking at very deep thunderstorm producing clouds. This is also accelerated, so it looks like it's going faster than it really is, but it really shows you the development of the different thunderstorm complexes that developed over south central Texas during this tragic event. And if you look closely, you could sort of see that there's actually some kind of mid-level rotation early on in this animation that you could see right here. And then as the event unfolds and the convection and the thunderstorm develop, you could see near the end of the satellite animation also the remnants of this sort of circulation that persists. And what this mid-level circulation does is actually it helps to destabilize the atmosphere through large-scale lift, which cools the air and makes the atmosphere more prone to thunderstorm development as this feature actually impinges upon this region. And so this was actually one of the aggravating factors in this event, this mid-level rotation creating this mid-level lift, very slow moving and basically stagnating over the same area for an extended period of time. Now, you may be wondering, where did this mid-level rotation come from? Well, as it turns out, this actually was remnants from ex-tropical storm Barry that initiated over the Western Caribbean as a tropical depression, crossed the Yucatan Peninsula, and then transited over the southern Bay of Campeche, developed into a tropical storm, and then made landfall over the eastern coast of Mexico around the town of Madero, Tamaulipas, before being downgraded back to a tropical depression as the winds died down. But as it turns out, the mid-level circulation remained pretty much intact as it drifted to the north via the prevailing winds that transported it over south central Texas by July 4th, 2025. And so if we zoom in here a little bit and take a look at the factors that actually brought on this tragic flooding event, so you had this, what we call this mesoscale convective vortex that was actually located right over the Texas Hill Country. This was actually the remnants of the ex-tropical storm Barry. You had the mid-level circulation that was sort of residual from that, provoking this mid-level upward lift, favorable for thunderstorm development in the Texas Hill Country, which is located right around here. And so that was one of the aggravating factors. An actual other aggravating factor was the presence, if I zoom out here a little bit, the presence of what we call a low-level jet, which is coming in from the south at low levels and transporting very humid and hot air towards the Texas Hill Country. And these low-level jets, as we call them, usually transport quite a lot of moisture in the low levels of the atmosphere. And we usually measure that with what we call total precipitable water values, which in this case were around 2.5 inches or about 50 millimeters, which is extremely high. And this basically is sort of a conveyor belt of this warm, moist air at low levels that's actually flowing northwards. We also call that transport integrated vapor transport. And when it's linked with low-level jets and atmospheric rivers, that could really cause quite a bit of problems. And so this air was moving northwards. It's very warm and moist. And when it is very warm and moist in these maritime tropical air masses, they have what we call pretty deep warm cloud layers. So warm cloud layers are actually defined as the height between the cloud base and the freezing level. And basically, the deeper this layer is, the more efficient it is at producing very heavy precipitation through the collision and coalescence raindrop formation process. And so in these maritime tropical air masses, you can really create a lot of rain in a small amount of time. Another aggravating factor was the fact that, if I zoom in here again a little bit, as this low-level jet was impinging in from the south, it was encountering the Texas Hill Country. So this topography here with this hilly terrain to the northwest of San Antonio and to the west of Austin. As this air actually impinges on this topography, it's forced upwards, which means that the air is going to cool, it's going to condense, and it's usually going to attain its level of free convection, meaning that thunderstorms are going to start developing in this area. And so you're producing a large area of convergence of air at low levels between the mid-level convergence provided by the MCV and the convergence at low levels provided by the low-level jet. And so when you have thunderstorm development in an area where plus the winds are quite weak aloft, that means you're going to have prolonged, very heavy rainfall produced by these thunderstorm complexes that actually start to develop. Another aggravating factor is the fact that this thunderstorm complex, known as an MCC, is actually developing, it tends to start producing itself also rotation within it. And so it most likely actually aggravated the rotation from the remnants of ex-tropical storm Barry and helped increase the convergence of air, which helped it rise even more. So definitely problematic. And let's not forget also that these thunderstorms that develop and remain almost stationary over these watersheds tend to produce what we call outflow boundaries, which is basically the downdraft of air coming in and hitting the ground and then spreading out along the ground. You can think of them sort of as mini cold fronts, and they will provide additional convergence of air along the topography between the low-level jet coming in from the south. And so you have all this convergence going on over the same area for an extended period of time with all these dynamical atmospheric factors taking place. And so this very, very heavy rainfall falling on these watersheds basically produced these very heavy rainfall rates. And you could see sort of an animation here from the radar out of San Antonio, and you could see around 3 a.m. these extremely heavy rainfall rates. You can see these reflectivities from the radar where you have these very intense and high values indicating that you have really heavy rain falling over the same region over an extended period of time. A flash flood warning was in effect for the area, but unfortunately, when these events occur very rapidly in terms of the river response, it becomes very difficult to be able to escape sometimes in these very vulnerable areas along the river beds. That's basically the explanation for this flash flooding event. It was basically a combination of different aggravating factors, whether it be the mid-level rotation left over from the remnants of ex-tropical storm Barry, low-level jet transport of very humid air northwards with very high precipitable water values, with integrated vapor transport and very thick warm cloud layers, producing precipitation efficient clouds with this thunderstorm activity, and of course the topography from the terrain that's tended to accentuate the lift, the outflow boundaries from the thunderstorm creating additional convergence, and also I did mention some backbuilding of thunderstorm activity due to this continuous fetch of low-level jet moist air from the south upon the topography, and so this really helps sustain these very heavy rainfall rates during an extended period of time. So there you go. If you enjoyed this video, don't forget to smash the like button below and subscribe so that you can be informed when new videos drop. If you'd like to learn more about the meteorological factors responsible for this Texas Hill Country flash flooding event, don't hesitate to go check out Tim Vasquez's Forecast Lab on YouTube, where he uploaded a excellent video explaining the meteorology behind this event. And if you enjoy weather and weather forecasting and or would like to learn how to forecast the weather yourself, then check out the links below my video. I have a visual severe thunderstorm checklist you can apply when stuck outdoors in menacing weather, an ebook explaining weather forecasting principles, and an entire course you can purchase composed of several video modules explaining how the weather works and the steps you need to follow to be able to make your very own successful weather forecasts. All right, until next time, for Master of the Skies, I'm weather forecaster Lionel. Stay weather-wise.